Hello, and welcome to the Orbital Exchange podcast, where we're on a mission to connect and unlock the full potential of the new space economy for all. I'm your host, Regan Hinchcliffe, VP of Public Engagement at Avro Aerospace. Orbital Exchange bridges bold ideas with real-world applications, bringing together innovators, entrepreneurs, and seasoned experts to shape the future of this rapidly evolving industry. My journey in aerospace began in May of 2024 after a 13-year career in digital marketing tech, building and scaling a successful company that I co-founded. My passion for space, something I just couldn't stop talking about, ultimately set me on a new path. That experience became the catalyst for pursuing what I now realize is my true calling, space. Every day, I'm inspired by the people I meet, the ideas we share, and the technology we're building. This podcast is my way of continuing those conversations and sharing them with you all. I'm joined by my co-host and technical moderator, Brian Zetland from Virtus Solis, a veteran aerospace expert whose career includes key contributions to the Canadarm and the International Space Station, and now to persistent, global, scalable energy from space. Together, we'll explore the cutting-edge technologies and opportunities shaping the space economy. So whether you're a student, an entrepreneur, or a professional, this is your space to learn, connect, and be inspired. So let's get started.
So we could probably get started if everyone's ready. So I'll give myself and our GATE team a brief introduction. So hi, everybody. My name's Ashley Dennison. Thank you so much for joining us. I'm a part of the Graduate Advanced Training and Entrepreneurship team here at the University of Regina. I'm currently working at home today, which is why I don't have a university background, but I got faster internet, which is great for examples like this, for video calls. So myself and then Hannah Tate, we run the center here, the GATE Center. And so, yeah, we work on advanced training. So that looks at career readiness. And then we also look with entrepreneurship, so that introductory phase, which is kind of where this all kind of comes together. We're very lucky because we're currently running a startup boot camp, which introduces students to kind of understanding how to get their businesses started from the ground up. So from ideation phase into kind of that implementation, market research, and then pitch finale. So it's very exciting. Hannah's busy at work, but then Satyam is also a part of that. So that's very great. So he's going to kind of be the keynote here and kind of telling us the ins and outs of his experience working on the NASA Space Challenge. But yeah, we're also very lucky to have him involved in some of our other programs that we're working on at the university as well. So without further ado, I will pass it along. So we do have Regan, Brian, and Satyam all on the call, but maybe what we could do is take some time and then introduce ourselves. So thank you everybody for joining us, but we'll get started here.
Thank you, Ashley. Thank you, everyone. Thanks for joining. Brian, Satyam, good to see you. Welcome, everyone, to the Orbital Exchange podcast, where we explore breakthroughs and opportunities shaping the new space economy. I'm Regan Hinchcliffe, the Vice President of Public Engagement at Avro Aerospace. And at Avro, our mission is to innovate and develop cutting-edge aerospace technologies designed to address critical global challenges, reduce costs for air and space access, and position Canada as a leader in aerospace innovation. And today we're celebrating a historic victory for Canada on the global stage. A Canadian team has won the NASA Space Apps Challenge, the world's largest hackathon. Out of nearly 10,000 teams worldwide, this extraordinary group from Regina, Saskatchewan has secured a global win, marking the first time for Canada to win an award from this specific hackathon. Their project, Asteroid Destroyer, was designed to assist Habitable Worlds Observatory by mapping observational paths to exoplanets and determining which ones are the most promising for further study. And this is groundbreaking achievement, proving that small teams from small cities can drive world-class innovation in space exploration. So joining me today is Satyam Singh, the lead developer behind winning this project. And Satyam is a computer science student at the University of Regina, a software developer at Offstreet, and a hackathon champion and legend here in Regina, winning 33 out of 41 global competitions. And as the president of the University of Regina Google Developer Group and the UofR Cybersecurity Club, He's passionate about exploring emerging technologies, solving complex challenges, and inspiring others to break into the world of tech and space innovation. Also with us today, the man, the myth, the legend, Brian Zetlin, a renowned aerospace engineer, entrepreneur, and educator. And his contributions include work on some of the most significant aerospace projects in history, including the ISS, the Shuttle Transport System, and Sea Launch. And he was also part of the team that worked through control regulations to enable the US and Canada collaboration with the Canadarm, one of Canada's most renowned contributions in space technology. So if anybody knows the arm that can move stuff in space out of that shuttle, that's what Brian helped get up there. So also as an adjunct professor at the University of Washington, he specializes in space systems and operations, and once again has worked at NASA, the FCC, and the Department of Energy. And he's also a key figure at Vertisolis, an ambitious project focused on scalable, sustainable energy from space. In this episode, we're going to dive into how Satyam won the NASA Space Apps Challenge in the process. It's going to dive into the innovative technology behind their award-winning project and why hackathons are a gateway into space innovation. Also going to dive into how Brian's own family played a role in advancing the space telescopes, contributing to the data sets that Satyam used to build his app, and what students, developers, and entrepreneurs can do today to break into this growing $1.8 trillion space economy. And before we begin, I want to thank Hannah and Ashley from Gate for hosting this platform. You ladies do such an amazing job there, and I'm grateful for you to give us this opportunity to speak here. And make sure to stay to the end because we're going to have some Q&A where you can have a chance to ask Brian or Satyam or myself some questions. And with all that said, let's dive into it. Satyam, thanks for joining us today. Welcome to the podcast. How are you doing?
Hey Regan, thanks for inviting me. Doing better now. It's a bit cold over here in China, so just trying to deal with it.
Yeah, it's pretty cold over here, that's for sure. So Satyam, you're not originally from Canada. Where did you come from?
I was actually born and brought up in Mumbai, in India. I moved to Regina in 2023, the fall of 2023, and that's when I actually started my university too. So yeah, that's when I moved here.
Nice. And so you've been involved in a lot of hackathons. I guess what got you into into hackathons?
Yeah, so the funny thing is, I wanted to get started with hackathons, not to learn about tech, like just learn the basics so that I can do better in the introductory CS class at UofR.
Yeah.
That's how I started. But when I won my first hackathon, like the first hackathon that I did, I was able to win like 2 prizes over there. It just felt like, okay, this is actually pretty fun. Like you can just do things within a weekend over like 24 to 36 hours and win
Yeah.
something. So that kind of gave me like a boost. And I was like, okay, I'm gonna do a couple more hackathons. And after that, it just kept going.
For sure. And I guess when you're looking at hackathons, how do you look them up or find them?
So I started from MLH website. Like MLH is one of the biggest organizations in the world that hosts these hackathons. So I
Yeah.
started with them, and after that, a couple more organizations came into the picture, like DevFolio, DevPost, and ETH Global. So these platforms actually host global hackathons all over the world. And like once you are in that community, that okay, you see you have been doing hackathons, you meet other hackers, so you just come across hackathons by itself. Like if there is any local hackathon taking place in China or in some small remote place as well, they will just share it with you. So that's how I like now I get to know about hackathons that hey, there is a hackathon in Saskatoon maybe or maybe in China. So that's how they just share it with me, and I will be like, okay, sure, let's do it.
Cool. And you mentioned community. Is there like a global community, like a Slack channel or something?
Well, there is a Discord server for,
Discord.
yeah, the one that I joined. But now I've created some of my own community. As we shared earlier, I lead the Google Developer Group. So I share a lot about hackathons that are taking place in Saskatchewan or Canada overall. So if anyone wants to like take a look at the hackathons that are taking place over here, they can join that as well. Even the NASA Space App Challenge, I actually shared about it over there too. I was like, hey, we are going this week, and if you guys are coming to say hi or something. So
Cool.
yeah.
Nice. Well, that's awesome. Thanks for sharing. And I guess you've been part of 33 hackathons. Is that correct, or 40?
It's like 41 hackathons that I've participated in, and I've
Yep.
won 33 of them.
133 of them.
Yeah.
Okay, and that's really cool to be able to win that many. And I guess what sets you apart? I guess why are you winning so many? What is the secret sauce, so to say?
So like after doing a lot of hackathons, you just realize that okay, these are the things that you are not supposed to do. For example, you're supposed to make sure that your project aligns with the theme of the hackathon and the fact that you are supposed to use certain technologies because each and every hackathon have their own theme. They have certain criteria that okay, you are supposed to use this and you are supposed to not use the other thing. So after a while, it just got me that okay, I'm supposed to do these things and narrow down all the features and just not be too like don't I shouldn't create like a big goal that okay I want to create that like next Facebook or something. You should try to implement like a small feature of Facebook, for example, and try to just make sure that it is good enough, and after that only go for the next feature. So initially I used to be like okay I'm gonna create like a really big project and go with that and maybe create a startup out of it, but that's like soon enough I realized that that's not how it works. So I started scaling down my MVP, and I used to be like, okay, I'm gonna create this particular features during the hackathon period, and maybe add these future goals in my presentation, so that they know that okay, this project is capable of being something like this. So it's about that, and again, how you present your project matters a lot too. So during each and every hackathon, you are supposed to create a demo video. So we try to always create a good demo video at the same time try to host a project online so that people can actually try it out and see like how the project works in real life, because if someone is actually interacting with it, then it's a different feeling. That's what we even did with the NASA Space Up Challenge. We hosted both front end, back and everything, and people were able to like work with it and like use it in real life. So that's how like I got the idea that okay, this is how I should approach each and every hackathon and just give my best. And after that, it depends on how the judging goes, right?
That's awesome. And I guess what do you love most about the high pressure environment?
Um, yeah, so I love the environment, like overall itself. Like when there are like 10 to 20 developers sitting at the same place, just building something cool, it's just like a different feeling. At the same time, it's not like people just code. Like in hackathons, they even host some side events. Like there will be some sort of competition where you are supposed to stack cups, and whoever has the highest stack of cups will win or something. So they host like these mini events over there too. So it's kind of fun. At the same time, you you build something within those 24 hours which is actually working, and you cannot do something like that without a hackathon. Like you can, but it's like high, like more likely you will not be able to do that, because uh that pressure actually creates something
Yeah.
which pushes you to build it within that time frame and get it working in reality. Because normally you face a bug, you spend like a day or two on it, but during hackathons you don't have that kind of flexibility. You can't spend a day on a bug, so you just create the entire thing within a day, and you try to find small hacks for it. So it's just the environment, the people around you, and the small events that makes it like amazing.
Yeah, that's really cool. I don't know if it was Elon Musk that said something around this, but if you say it's going to take you to the end of the month, or you set the date for the end of the month to accomplish something, it's going to take you the month to do it. But if you set the date for a day later and are strict to that, it'll take you a day, like cleaning a room or something. So
Yeah.
that's really cool, Satyam, and you've probably gained so much experience going through that. What kind of career opportunities have you gained from being part of these hackathons? And I guess how would for the audience here, what would be your advice for getting started in hackathons?
Okay, so for the career opportunities, I would say it was really useful. Like my first internship and full-time job was actually through hackathons as well. Like I joined Push Protocol back in 2023, and I joined them because they knew my hackathon journey, and I used to post a lot about it on my Twitter account, which is also known as X now, and on my LinkedIn. So they used to see that, okay, I like build stuff and do like hackathons. So that's how I got my first internship. And and after that I joined them full time. But after moving to Canada, I wanted to join like a Canadian company. And even though people say that for newcomers in Regina or in Canada overall, it's kind of hard to get their first like job, full-time job. But for me, I believe hackathons played like a major role because they saw that I have I have experience of working in global environment. I've done competitions globally, so it wasn't hard for me to get it. Like I worked at FCC, which is also known as like one of the best companies to work for in China, in my first year itself. And after that, I got a return offer from them as well. And after that, I joined Off Street, which is like one of the fastest growing startup in Saskatchewan right now. So I believe hackathons played like a major role in it because people like to see like the developers are building just for the sake of building. Like sometimes it's hard to even explain it to people that okay, we are just building because we want to and not because we want to create a startup out of it.
Yep.
So CTOs and companies actually like that okay, people are building things, just for the sake of building it. So I believe it really helped me out, to uh, show that okay, I'm different and I have like better capabilities, maybe stand myself out from the application pool, I believe. So after that, for the hackathons, yeah, if you want to get started, I would say it's more like it's difficult to do your first hackathon, but if you do it, if you just go for it, you will just understand everything by yourself. Like I wasn't prepared for my first hackathon. I wasn't like I didn't have any technical capability. I didn't even have a laptop at that time. Actually, I borrowed it from my sister, and I just used it for a day. And after that, I gave it back to her. That's how I did like my first 5 hackathons, I believe. So it's not like you are ever like completely prepared for your first hack, then it's all about you go all in and you will just figure yourself out. It's just about having that kind of mindset that okay, if I go in, I will just figure it out by myself and I should be fine. And you should be fine. Like there are a lot of people that actually wants to help. Like I still remember there were a lot of Waterloo students and U of T students that helped me out in my first few hackathons, and they're really eager to help you out. They are like, okay, if you want help with anything technicality wise, we are there. If you need help with the presentation, we are there. Like whatever you want to try, we will let you do that, and so that you can learn from it. And like once you know that okay, people are there to help you out, you will feel even more comfortable, I believe. So it's all about just trying it out first, and you will just figure your way out from there.
That's awesome. That's a great story, Satya, and I'm sure all the people that helped you out in the early days are pretty darn proud of what you and your team accomplished with the NASA Space Apps Challenge. And I guess now we can get to the good stuff there. So let's talk about that. We got through your history of your hackathons and what you learned there, but let's get into the big one here. So let's talk about from the very beginning. How did you get involved in the Space Apps Challenge and what happened? Just kind of go from the very beginning of seeing it and getting involved and how it built out in the process there and what the challenge was and what you accomplished.
Yeah, sure. So I actually saw a LinkedIn post by a really good friend of mine. His name is Logan. So I saw it on LinkedIn, and he was like, "Hey, we are hosting a hackathon in Saskatoon." So I tagged one of my teammates, like Satyajit. I was like, "Hey, let's do it." So he was like, "Sure," because we wanted to put our name outside of Regina as well, like in Saskatoon and other places. So we were like, "This will be a great opportunity to do that." And we grabbed other friends of mine, like 2 other friends of us, and we decided, okay, we will go for it. We went there, we drove overnight, and we reached there by around 7 a.m., I believe. So we left around 4 and reached 7 to 8 a.m. And after that, we stayed overnight at the place, like at the University of Saskatchewan. And over there, they didn't have like a like we were not supposed to stay there, but we just stayed. So
Yeah. The breaking rules is probably a
yeah,
part of hackathon, isn't it?
yeah, I guess
It
so.
literally has the word hack in it. So yeah.
Yeah, Yeah, so they actually had a really good student lounge over there where we stayed overnight. They
Yeah.
had like really good couches, so we were just sitting over there and
You eat from the vending machines, have some chips, and
yeah,
that's what you've done.
we grabbed some Monster, not chips, but Monster from there. Gotta stay
Nice.
up, like.
Yeah.
So we started working on it, but before we started working on the project, we had to choose a challenge, and that was actually the biggest challenge, I would say, like choosing the challenge, because there were around 40 challenges over there that we were supposed to choose from, and it's kind of hard to like just choose one challenge because all of them look really good, right? And you have to like come up with something that, okay, I can maybe build a solution for this particular challenge that they have posted. So we looked into some of the challenges and we were like, hey, this particular one, like the exoplanet one, is something that I think we can build really well because we have experience with 3JS, which is a 3D web library.
Mhm.
I have worked with it a lot in the past. Like I used to build video games on websites using 3JS. I was like, I have experience with it. I can create a proof of concept for sure. And two of our friends are from data science department at UofR. So they were like, okay, they can modify the data to like work with it. So we decided that okay, we'll just go with it. After that, the next few hours were basically to create a proof of concept and to see if it will actually work or not. Because rendering around 5,000 planets on a website is kind of difficult, especially if it's 3D. The three-dimensional models on websites makes it a bit laggy. So we wanted to make sure that it's gonna actually work. Like if it's gonna not just break the entire website and make it look like a crappy web platform. We didn't want that. So we tried that first. I just rendered like 5,000 planets and I realized that okay, it's working fine. We can actually go ahead with it and we can just go ahead with this particular challenge. Or else we would have pivoted to something else. But after seeing that, we
What
were
were
like,
there any? What were the other ones that caught your eye? Any other specific ones that are worth noting?
I don't actually remember them right now, but there
Any
were
monsters?
yeah, there were a few more related to exoplanets too, and there was one which was basically to help people learn more about space using some sort of story visualizer. So
Yeah.
basically, maybe creating a video game or creating some sort of exercise for astronauts. Even that was one of the challenge that a team actually picked up at the hackathon. Uh, and there was some other really good challenges, but I'm just not really aware about them right now. It's been a while. So after that, we started working on a project. We just like started clearing it out that okay, we got to make sure that a UI looks good. We got to make sure that we are deploying it from the start point itself because deployment is kind of difficult because sometimes you get an error at the last point, which breaks your entire website, and you just don't know what to do. And as per the rules, you can't really push any code once you are done with the hackathon. So even if
Mhm.
you realize that okay, there is a bug that you want to fix, you can't really do that after the hackathon deadline. So we had to make sure that it's working fine. So we did that, and at the same time, one of our teammate came was working on the presentation because we had to make sure that people know what it is about. So at the same time, he was working on that. He created a logo too. If you see our logo, so the funny thing is, Astra Destroyer actually came from a like the name came from a cat on
It's the
social
name of a
media.
cat. Yeah, it's
Yeah,
a viral TikTok video slash
yeah, yeah,
Instagram reel. That's an interesting couple who have some
yeah,
really good videos. And yeah, so I picked up on that as well, and I loved how you put the cat in
yeah,
there and made that reference. So that's really cool. So I guess maybe let's get visual.
yeah,
So do you want to share your screen
yeah,
and
sure.
bring up because I really want to contrast. I really want the audience to see what problem were you set out to solve
Yeah,
and how was your approach? Uh, like how did you take that approach to solve it that puts you in a position to win? Like really, what set you apart?
sure.
So
So I'm going to reload it first so that you can see what a normal user sees. So
yep.
normally you will just see this thing. And as you can see, it is interactive. Like you can use your mouse in order to hover over it and like move it around. And if you
Yep.
can see this particular design, like this pattern, it's kind of
Yep.
similar to what NASA has on their website. I will show you that too in a minute. And I believe that was like one of the things that did set us apart, because first we were thinking that it's a bit weird because this particular pattern was was not something that we were sure about if it's actual pattern or not. But later on we realized that NASA has a similar one. So if we go to NASA's website and just zoom out over here, then we will see a similar pattern. So
What is that pattern?
like this one, I'm not sure what it's called exactly, but if you see the design, like if you zoom out, the way
Yep.
it looks like, it's kind of similar to our own project over here. So that's actually something I believe that set us apart, because we didn't have a really good data set that we could just directly use. So we had to make sure that we scale it down in order to convert it into a Cartesian plane and then use it in our web app. So we had to do that. Like one of our teammate Kapish worked on it and made sure that it's actually perfect. And I believe like this is like one of the like best way to show it, because if we zoom out, it will look exactly same as NASA's exoplanet web app.
Yeah, yeah,
And
and so okay, so we've got the end product here,
yeah,
and it looks really cool. I want to dive into what it's doing, what it's going to help NASA do. But
yeah.
first, let's go to the basics. Like what was given to you, and what was the process to get to this, and then what is this solving for the world?
Okay, so we were only given a CSV file, like an Excel sheet,
So
with
a CSV file, and just pretend people don't know what that means. So you're given
uh,
a database
yeah,
of,
we
of
can say,
coordinates.
yeah, not coordinates. It's exactly, it was basically the distance from the sun.
Yep.
So we were just given that, and after that, we had to actually convert it into a Cartesian, like convert it into coordinates in order to put it in a web app.
Yep.
So we did that. Like that was actually the main process of it, like of the entire project. And after that, we were just given the problem that we are supposed to characterize it. They didn't tell us to make like a 3D interactive website or anything. They were like, okay, we need to characterize exoplanets, but
Hmm.
we decided that okay, making a 3D platform for it would be like perfect, because this is space, right? And it's better to visualize space. So we decided that okay, we'll just go with a 3D one. And after that, we came up with the idea and divided the task.
Yeah, and so this particular challenge, how did other people approach it? When you said you didn't have to make this 3D, what were
Yeah.
some other approaches?
Some of the projects, like in the finalists itself, like they selected 40 finalists, right? So I was just taking other projects and I saw one other team who worked on the same challenge, but they didn't really show all the planets. They just created a proof of concept, which doesn't show any of these patterns, but it only shows all the planets. That okay, you can click on a planet and like learn about it. But we can do that over here as well. Like if we add any filters, let's say I'm gonna add 1 lakh sound to noise ratio, and let's just talk about gas giant, apply filters, so we can see all the filters, right? So if we click on
Yeah.
any of these panels, we can learn about them from the right panel. So I believe that project only showed this. They just had this feature where you can click on a planet and learn about them through the side panel.
Yeah.
So I believe none of the projects had all these features that we had. So that kind of set us apart. And it wasn't really visual, like it was visual, but more of a manual thing from their side.
For sure. That's great stuff. And so what is this? Let's contrast this. So I guess what is this going to help NASA do now
Yeah,
that they
sure.
have this?
So instead of checking each and every exoplanets, they can use certain filters from a platform itself. Like instead of using an actual telescope, they can just use the telescope config from here and change the settings as they want, and just find certain exoplanets that they should actually look for, and
Hmm.
like send a probe to study more about. And that's what.
So they're going to use this app to send probes?
Well, we have a meeting with them soon enough, so maybe they
Yeah.
will.
And I guess like so NASA didn't have this before. Is that what you're saying?
They don't really have what we built. So over here you can see other missions, like what the missions were about, and the different observatory and the planet types. But you can't really like classify those exoplanets. So that's what actually we built. So NASA didn't really have it, and I believe if NASA wanted to build it, it might take them a bit longer than we did, because they have certain things that they have to make sure, right? They have to follow a certain criteria and a certain flow. So they have to take like longer than what we take in order to build something like this.
Yeah, and so that kind of brings us actually before we get into that part and why NASA put this hackathon on and all that. Really, Brian, do you have a family connection to somebody that helped get the data to provide Satyam with the data to be able to build this? Can you maybe talk about that a little bit?
Sure, briefly. Actually, two connections. Way back when the Hubble was being refitted with new spectacles. This is probably well before the memory of most of the people who are participating in the podcast. A friend of mine, another aerospace guy, was given the task of sending up on the shuttle the new optical system. The Hubble had been launched with an improperly aligned optical system, and I got to participate in that study. But moving fast forward, I can't mention his name because it's proprietary information, but a very close family member was instrumental in developing the Webb focal plane. And as people probably know, both the Webb and the Hubble were optical, not radio telescopes, and able to reach out these extraordinary distances. May I ask a couple of questions of Satyam?
Yeah, of course. Go ahead.
Okay.
It's all yours.
The first one has to do with, I taught for a long time at the University of Washington in two departments, mechanical and computer science. We had hackathons. And for those of you who are looking to either break into space or shift careers or look at a new set of studies, present at those hackathons were hiring managers from every high-tech company in the region, and that covers a lot of ground. Open campus, they were invited to come and look. And I oftentimes sort of mediated or set up meetings with people with Microsoft who were interested in talking to the people who were, so earnestly working on the hackathons. Also, we use them for capstones, which I'm sure many people are familiar with. My question, as an old hardware and hardware systems guy for Satyam, is when you sit down with your team or stand up or throw potato chips at each other, how do you organize your work teams? I mean, surely it's more like an orchestra. Are you the conductor? Do you set out tasks? Is this a linear process or is it collective? How do you set up working the problem?
That's actually a really important thing when it comes to hackathon. So specifically when you don't really have a single team for each one of them. So I do have a team in China that I go in hackathons with, but when I go out of China, I have to like create a new team. So what we do first is basically create tasks that okay, first we have to do this, then this, then this, and we try to see that who actually wants to pick up these tasks, because each person has their own capability. Like let's say some guy has more experience in backend, someone has more experience working with data. So we see that okay, this person has more experience, so we'll just assign this task to that person, unless he or she decides to take it by themselves. So that's how we normally approach it. It's better if they take it by themselves, because then they are more likely to do it even better with their heart into it, because they would be like, okay, I actually took it by myself, so I need to do it. And the thing is, in accidents, sometimes you face problems that you were not aware of can be a problem, and in those kind of scenarios, you have to be like, okay, how do I approach this particular problem? So in that case, you have to ask your teammates that, hey, I'm facing this issue, so how can I do it? And that's how we like collaborate too at the same time. So it's more about, yeah, like just creating tasks and making sure that people are actually willing to work on it. So just assign it beforehand, and after that, if they're facing any issues, just make sure to keep check on them that, hey, are you having any issues with it? Can I help you in any way? So that's how I do it most of the time. It kind of works out from there.
That's great, Satyam. Before you stop sharing your screen,
Mm.
I'm seeing here that you've identified a planet that's not habitable. Can you maybe find a planet that is habitable for us?
I would have, but the thing is, our API credits have been expired,
Oh yeah.
so it's gonna give you a not habitable right now for a long time. It used
So
to.
we may need it pretty soon here.
Yeah. We're gonna need it pretty soon. I guess we're just gonna add AI to this, and then we're gonna find all the habitable worlds in the universe, right? So okay, you can stop sharing your screen now, Satyam, though.
Yeah.
Brian, do you have any other questions there around that? That's really good insight into your process, and I think good functional work or good functional info for everybody that's listening.
Well, you mentioned AI, and of course, this is one of the myriad applications where it can improve resolution, can do a lot of collation and reassorting of elements and factors more quickly. But to go back to the question, your program, as you developed it, were you collaborating with NASA or were you doing this independently?
Sorry, your voice broke a bit in between.
I'm
I
sorry.
could hear you fine, Brian. Go ahead. He was asking if you worked with NASA directly with this.
No, not really. So it's more like you develop it independently first, and first you win the local hackathon, and after that your like project goes for the judging by NASA. So it's more like first you have to win it, and after that, if there are chances of working on it further with NASA, then we will get to know about it soon enough, and that's how we'll go with it further on.
So you don't, at least with respect to this particular project,
Yeah.
you don't engage on an intern basis.
No, no, not really. It's more like they just judged our project.
Because everyone should know that
Yeah.
despite right now the quasi freeze, NASA routinely brings in many interns, and it should be said as well. I think again because one of the reasons I like participating in this particular podcast, because a major part of it is about young people and people who want to move into space operations. NASA has more administrative staff than it does scientists and engineers. There is room for virtually any profession, from truck drivers to observatory staff, and for people who want to engage or for the first time approach. I urge you to look at opportunities. There are a lot of websites, but for NASA in particular, of course, they have their own. Overall, in technology programs, I would suggest that people go to USA Jobs, one word, USAJOBS.com, which lists all government work in the United States, including scientific, engineering, biology, and so forth. And I do have another question. When you engage, you've got this incredible Joe Louis track record of winning fights. When you engage, when you sign up for a hackathon, how much latitude is there for you to choose your challenges?
So most of the time we don't really get challenges. We normally get themes that you have to build something around this particular theme. For example, social impact, nostalgia, or perspective. But it was like this particular hackathon was a bit different, where they give you certain challenges to work on. So it depends from hackathon to hackathon, but most of the time we have like a broad spectrum to go and figure out which problem we want to solve actually. But yeah, like this one was a bit different. But actually, these kind of hackathons are better because we actually know that there are like these 40 problems that we should choose from, so that we are on track after choosing the problem, and we don't really have to like first create a solution and then find a problem for it. So yeah,
Well, as a developer, what are you doing now for your current employer? What project specifically?
Currently, I'm working on something called reports, and it's basically for universities. So Offstreet basically does parking validation for universities and parking operators as well. For example, UCLA uses it, and a lot of other universities in states. So I work on a lot of different features. We don't have like a specific thing that I focus on every day. So it's more like, okay, right now we are working on something new, like a new project. Then I will just move over there, or if there is some sort of bug, then I can move over there too. So it's kind of flexible because the developers team is not like too big. It's like 5 people right now. So I get to work on like different things and actually build like end-to-end features over there.
Well, go Bruins. UCLA is my alma mater. I'm glad to hear that. Now let's turn this around. I'm the graybeard here. Again, your record is stellar, and I'm sure a major part of that is strategizing as well as being able to think and work quickly on the fly. What advice would you give peer to peer to people in your age range and with similar interests and skills, but perhaps not as skilled organizationally as you obviously are? What kind of advice would you give to people who have similar objectives to yours?
I would say just give it a try. Doesn't matter how skilled you are. When I started, I wasn't skilled at all. I was just like a person who wanted to try something so that he can be good at his introductory CS class. So just give it a try. You will figure it out by yourself. It's more about doing your first thing, like doing your first competition, taking your first CS course, of taking like building your first tech project. It's just like the first one takes a while, takes a lot of effort, but after that you will just figure it out by yourself. So it's
All right,
like,
now I've got a money question for you.
yeah, sure.
And I appreciate your time as well. I know that you're very well occupied. I work for Virtus Solis Technologies, and we're building solar arrays, not individual satellites, essentially to convert photovoltaic energy into microwave energy. And there are a lot of issues which we've already solved, having to do with energy efficiency, cost per unit of electricity. One of our multiple challenges, again, which we're now working our way through with interns, is essentially orbital mechanics. So how would you, for instance, lead a team of either interns or well-seasoned engineers in using the HWO program as an example for satellite management, orbital management, traffic management? The reason I'm asking you is I want to plagiarize you. I'm speaking at a conference very soon in a couple of weeks at International Academy for Astrophysics, and our unit has to do with space traffic management. So how would you apply your extraordinarily high level of resolution to objects that are three orders of magnitude closer?
So I don't have much information about it, but like I don't have much knowledge about energy either. But I'm gonna just try to convert it into tech and try to see if I can answer that. So first, I will probably try to define the objectives, and since it's more like space traffic, if I'm not wrong. So again, we can just use a 3D platform, like a 3D interactive web platform. Put everything over there the same way how we have for exoplanets, and maybe add filters on. Okay, these are the objects in space that can maybe come back to space or come back to Earth or something, maybe in the next 10 years or something. Add filters over there and show it in that particular way that, okay, if you add the filters and click on apply filters, then it will highlight those particular objects. And at the same time, add speed on it, depending on what the actual speed is. I think we can calculate that easily. So just do that and maybe visualizing it would be a decent thing to do initially, and after that we can just go from there, like decide that okay, maybe yeah, like this is how the space traffic is right now, and it's going to be like uh, this particular way in the next 10 years or something. So I think
I
that's
think Satyam just won the Virtus Solus hackathon.
Well, now see, you got me intrigued. You sound like one of the students I have that are smarter than I am, which by a long shot. One of my esteemed colleagues and friends on here is Cameron Greatorex, and
Mm,
Cameron's organization is developing a type of satellite robot, uh,
mm,
one of which of its duties would be to physically optically characterize
oh,
satellites by approaching. So if you were going to do a route map,
yeah,
develop let's say you're looking at half a dozen superhighways traveling around the Earth, and you're trying to figure out the best way to conserve fuel, moving from one satellite to the next in that orbit. Do you think you could develop an algorithm that could manage something like that?
well, definitely it's doable. It's more about the more information I get and the more knowledge I get about orbits and how the speed works over there. I think that an algorithm can be made for it, for sure.
All right. You may be in trouble now, Satya.
As long as I have a good trouble.
Yeah, and I guess that goes to the next point. So like we got 10 minutes left. So I guess why does NASA have a hackathon? What is the purpose behind it? And why don't they just hire a team to do it?
Yeah. So I believe they have this hackathon with the same reason why other companies host these hackathons. Like there are other companies too, like KPMG that host like annual hackathons. It's mainly to encourage new developers to build solutions around what is actually needed in the world mainly, and to put out some of the problems that they are facing personally, but it's gonna take like maybe a while for them to build a solution around. And it's more like my own point of view, so I'm not sure if it's like different for NASA, but yeah, that's what I think and that's what I believe. Because for this particular project itself, it would have taken them months to build it, if not years. So, but we were able to build it in 24, 36 hours. So I believe that's one of the main reason behind putting all these hackathons every year. And again, to show that okay, there are things that you can build around space without having like a lot of knowledge in space, basically.
Yeah. So speed is a big thing,
Yeah,
and yeah,
speed.
and no red tape.
Yeah.
And I guess they're not having to hire people and put them on employment contracts and all that stuff. And they was there a cash prize for this?
Well, there was a small cash prize for the local hackathon, but that was, I believe, more by the university itself, which
Right.
was like $200. But now we have been invited to visit NASA in
Yep.
June. So that over there, they will be giving us some sort of materialistic prize, like more of a medal or a certificate, I believe, that we
Yeah.
have won the hackathon. Like we just got the invitation for it yesterday, I believe. So we are just preparing for it to go there now. But there wasn't any like cash prize by NASA. Normally there are good prizes in hackathons, like
Hmm.
big ones, but
Well, it should be said that, and more is, I mean, here we are talking about
yeah.
hackathons as hiring events. I can tell you that again, I've participated in a lot of them, and not just limited to here in Washington. Um,
Mm,
all of the high tech companies, this is where they get to find out what HR doesn't tell them, what recruiters don't tell them. This is where they see how people cooperate on complex projects in teams. So it's a great economic opportunity, job opportunity for people.
yeah, yeah, definitely. A lot of companies actually do that too. Like they will just directly hire people from hackathons, and
Right?
they put their booth over there, and they'll be like, okay, this team is pretty decent. We'll just hire them.
Yeah.
Nice. I guess might as well get to questions, but any last remarks, any last words of wisdom? I know you mentioned, I think the moral of the story is action creates data. You either win and you get more confidence, or
Yeah.
you fail and you learn. And then keep taking action. Action is what produces information. So that's a great way to exemplify that, Satyam. I think you're an outstanding individual and very, very proud that you decided to come on the show with me and Brian, and glad to speak with you. So any last words of wisdom for everybody on the call, and then of course everybody that's going to see it when we post it later?
I would just say, go for your first competition, for your first hackathon with your friends. Don't be uh, don't be scared of losing. Like, fear of failure should not stop you from doing things that you love, you know. So just go for your first hackathon or competition. Maybe drive there or do it online, whatever works, but do it.
Awesome.
Regan, let me point out, Chris Hack has just posed a great question. I won't take up time, but this has to do with Dyson spheres, and he's saying here there's probably not enough time to answer the question.
Of
Satyam,
course, Chris. Yeah, I know Chris. So of course he's about Dyson spheres. Nice one, Chris. Go ahead.
Satyam's reading it.
Oh, okay.
I'm not sure if everybody else on the call, maybe we could just like read the questions out loud, or
Sure.
I can help manage them. But so
Yeah.
the question is just like, um, and the new awareness into megastructures in our universe. Would Satyam's app be used to track or map Dyson spheres and the new awareness into megastructures? Also, thoughts on quantum computing and its effects on cryptographic equations slash algorithms in respects to our global internet security, servers, and blockchain infrastructures. Will we see these dependencies in the new computing, or do the risks outweigh the benefits?
Uh, Awesome. I have some inputs on it. Uh, for the for mapping those mega structures, I believe that's definitely possible with our app. And on quantum computing and its effect on cryptography equations algorithms, like I've worked in blockchain for like 1.5 years or 2 years, I believe. So I have like decent experience in it, and I would say it's more about making things like less vulnerable than making things like unvulnerable at all. Like that's not possible. Things will break either ways. So it's more about making sure that it's difficult to break them. And quantum computing, and with the help of the new chip that Google released recently, I'm guessing things gonna get even much more easier to break into. But it's more like how hard we can make it to, you know, just get into it, because not everyone gonna have those chips in their home lying around. So it's more about that, I believe, from my perspective. But like Brian might have better inputs on it.
Brian?
Oh, my response to this is that I'm intrigued to see that Chris, you're assuming that Dyson spheres exist. I'm not quite sure how to read this. Dyson was not the only person to conceive of this, as well as Dyson rings. There are a couple science fiction authors who have done a pretty good job of exploring this. But insofar as looking at megastructures in the universe, it would seem to me that what you've already created, the HWO program, can do a fairly good job of macro characterization, although you're really involved in micro in characterizing small objects, exoplanets. So, and Chris moves over here to global internet security and internet servers and blockchain infrastructures. Chris, you're talking politics here. This is, I quite agree that we could use systems such as Satyam's to look at this stuff. But your last phrase is here, do the risks outweigh the benefits? Satyam, I'd like to hear your comments about that as a young, new, fresh force in the field.
Honestly, I'm not the best person to comment on it, but I would say like there are risks for every single thing. Like whatever we build, like we build laptops. Laptops has its own benefit and its own risk. The risk are basically people getting attached to it a lot. They doom scroll on YouTube on other web platforms, but it's more about using it in a good way. Like you can't really uh, define a product by its risk because it's gonna have risk for sure, but it's all about its benefits too, right? So it's kind of complicated and at the same time not something that we can define that okay maybe
Yeah,
this
you
sort of
don't let risk stop you. You
yeah that's
design, you look at risk mitigation, but yeah, I agree.
I like to look at these types of questions in the form of look at Star Wars and the Force. There's always a balance to anything. And any great technological achievement can be used for great harm and great good. And there's just always going to be that balance in my perspective. And
Yeah.
so which side are you on and who's in charge? And yeah. But yeah, that's if there's no other questions, that's the show. Everybody, thanks for joining and hope you enjoyed. And for the people listening after, hope you enjoyed. And Satyam, thank you so much for coming on. Congratulations on everything. You're going to be a very successful individual. You already are in my eyes, and I know that you're going to be meeting with the Canadian Space Agency pretty quick here and NASA too. Is that correct?
yeah,
You-
I have a meeting with them later this month.
Awesome. So onwards and upwards into space thereafter, man. We're getting Satyam to space. So Ashley, thanks so much for having us and great seeing everybody, Brian. And yeah, without further ado, to
Thank
space.
you all.
See ya.